So first of all, thought it would be useful for you to have a little overview of what your choice of courses and stuff are at DLD College in London. So the main two courses we've got, first of all, you may be new to the UK curriculum. So we do what's called an international GCSE. Now this covers topics from number, algebra, geometry and statistics. And you've actually got a choice of two tiers of entry. We can do what's called the higher tier, and that is grades 9 to 4, or we've got the foundation tier, which is grades 5 to 1. And so in the UK, we no longer grade GCSEs from A to E, we grade them from 9 to 1. 9 is the best grade you can get, 1 is the worst. So you've got a choice of two tiers here at DLD College London, and both those tiers, you do 2 exams. They're sat at the end of the year, and it's 2 papers which are 2 hours long. Typically, a GCSE is actually covered in 2 years, but we at Abbey College DLD cover it in 1 year. So it's quite an intense experience. Often students that come to us maybe have had a bad experience of teaching of GCSE maths before, and they kind of want a quick fix, and we're kind of experts at doing that. As I said, it's quite an intense delivery. We cover all the key points on the syllabus, really exam focused lessons, and hopefully you're going to see a sample of that today. Just to give you an insight into the course as well, the good news is both exam papers, they allow calculators to be used, and there is no coursework, which is also a good thing, because coursework in maths, in my experience, is a bit of a headache. If you want to find out a little bit more about the course as well, we do what's called the Edexcel exam board. So that's GCSE. If you've got any questions about that, I'll pause in a moment and we can do some quick Q&A. The next choice of course you've got is what's called A-levels. These are a post-16 qualification in the UK. So typically you do GCSEs first, and then you would do an A-level. So this is for people who've already done a GCSE, or they've got their equivalent qualification from their home country. Now, when we do A-levels, the course is split. There's pure maths, which you probably know as algebra, and then there's applied maths. And applied maths will be statistics and mechanics. Now, I know from experience, lots of students from the likes of countries like the Balearics and Russia and China to some extent, they often haven't covered statistics before. So that's something that's quite new, but often the pure maths, the algebra stuff, and the students that come to me often are very strong on that. In terms of the A-level course, it's 2 years of study, and the examination is at the end of the second year. We do 3 exam papers, 2 are on pure maths and 1 is on the applied. Again, calculators are allowed, and again, we do the Edexcel exam board. So that's the A-level course. I see there's a couple of things going on in the chat, so I'm just going to flick over to that. Okay, cool, no questions as yet, and that's wonderful. So that's the main 2 courses that we offer. Now, there are some other options open to you. So we also what's called further A-level maths, and this is studied in conjunction with the regular A-level program. So the way it operates, you do an A-level in maths and you do an A-level in further maths. We essentially do, the way we deliver it is we do the A-level maths first. So rather than being a 2-year course, we deliver that in 1 year. And then after the first year, if you successfully pass all the exams at the end of that, in the second year, you go on to do the further maths course. So the further maths course is a really rigorous course. It's quite challenging. It's quite challenging even to deliver, as it's very conceptual in places, some of the maths that we study. It's particularly appropriate for those that want to aspire to do a highly numerate degree. So if you've got aspirations of going to somewhere like LSE, you want to do I don't know, medicine, or you want to do maths or engineering, this is a really good course for you. Okay, so again, if you're doing further maths at A-level, it would be 2 years. The first you'd be doing that A-level, and then you do that in the second year, the further maths A-level. There is another option course-wise open to you, which is also the International Foundation Programme. This is a 1-year course for those that want to get into a UK university that's affiliated with it. It's slightly more restrictive in terms of university choice, but it is widely recognised as a good course by a lot of our universities that are in partnership over this course. So I think that's probably something the marketing team, John and Yuki, etc., can give you a few more facts about. So that's the main courses, which then brings me on to the lesson that I'm going to deliver today, which will be on straight line graphs. I'm just going to take a pause there. If anyone's got any questions, if you want to type them in the chat bar now, feel free. Otherwise, I will crack on with the lesson. Okay. So, hello, Aruna. Okay, right. And so what I'm going to teach you today is this. We're going to do a small lesson, a little sample lesson on coordinate geometry. So coordinate geometry, you might know it by a different name. This is called straight line graphs. So we've got a few objectives of what we want to be able to do by this session. So hopefully we'll be able to discover the connection between the equation of a straight line and its graph. I want us to be able to recognise the effect that gradient has on a line, locate an axis intercept, and complete some sample GCSE questions. So that's kind of our objectives. Let's see how we get on with this. So I'm now going to flick over. I'm now going to share a different screen. Bear with me while I do. I'm relying on John and Yuki to tell me if my screen hasn't changed. Otherwise, I'm going to assume everyone can see the graphs. Okay, so I'm going to plot a few graphs for you. So this is a great website, this one. This is called desmos.com. This is a free internet-based site where you can draw any graph you want. If you're really sad like me, you can even put it on your phone as an app. So I'm going to draw some graphs. First graph I'm going to draw is the graph of y equals x, not that one. I'm going to draw the graph of y equals x plus 2. So you should see this purple line, and it's a straight line that crosses, this is called the y-axis. I'm hoping you can see my mouse cursor. It crosses the y-axis at 2. So what we're going to be looking for is a connection between the equation I've drawn on the left-hand side and where it's crossing that y-axis. And if I hover my mouse over it, you can see the coordinates of where it crosses is the point 0, 2. Now let's do another one. Let's draw the graph of y equals x plus 3. Let's draw the black line, and again, you'll notice that this one crosses at 3. We might start, hopefully, spotting a bit of a pattern here. I could draw y equals x plus 4. That crosses at 4. Similarly, I could draw y equals x minus 4. That's crossing down at minus 4. And we've got the graph y equals x minus 1. So we've got a few graphs here, and hopefully we can spot some patterns. So the first one I drew was x plus 2, and that crossed at 2. X plus 3 crossed the y-axis at 3. X plus 4 crosses the y-axis at 4. X minus 4 crosses at minus 4. We can even make some predictions. X minus 7 will cross at minus 7. In fact, let's check that one. So I could do y equals x minus 7. It's going to go slightly off screen. If I scroll down, you can see it crosses at the point minus 7. So basically, what that's telling me is a little bit of a pattern going on here, okay? This number at the end, that tells us where that crosses the y-axis. And we've got a special word that we use to describe that. We call that the y-intercept. The y-intercept is where a graph crosses the y-axis. Now, there are actually other patterns going on here as well. All those equations I've drawn down the left-hand side of the screen, they all begin y equals. They begin y equals x plus something or x minus something. In fact, that x, I'll change it. I could change it to a 1x. They've all got a 1x in front of them. Now, I don't know anything about your background in maths. Some of you may realise this. Some of you may be, if you haven't done any maths for a long time. But in maths, we're all really lazy people, mathematicians, essentially. We don't like writing 1x. We just write x. But when you've got x, that means you've got 1x. So all these graphs, they've all got a 1 in front of the x. So they've all got something in common. So if I go back to the drawing, what that means is there's something in common with all these drawings, all these straight lines. And the thing they've all got in common is that they're parallel. The parallel means they've got the same gradient or they've got the same steepness. In other words, they're going up at the same angle. So we've basically got two facts here. The number at the end of the equation tells you where it's going to cross the y-axis. And the number in front of the x tells me its gradient or how steep it's going to be. And because they've all got a 1 in front of the x, it means they've all got the same steepness. x. So that's the first thing I want to show you. The next thing I'm going to show you, let me just clear these ones off my bit of graphing software. I'm going to draw a few more lines for you. Excuse me, referring to my notes here. So the next line I'm going to draw is I'm going to draw y equals x. I'm also going to draw y equals 2x, and I'm going to draw y equals 3x. So I've drawn 3 straight lines. Okay. Now you'll all notice they haven't got a number at the end of them. So if you keep an eye on the black line, I could call this one x plus 0. The line essentially doesn't change when you put a 0 at the end of it because you're adding nothing onto it. In fact, all these lines, they pass through the origin, they pass through 0 as you would expect. The only thing that's changed in this scenario is that I've changed the number in front of the x. So whereas on the previous graphs I drew, the number in front of the x was consistent, now the number in front of the x is changing. So y equals x, or y equals 1x, is kind of a fairly flat line. Then you've got 2x, which is steeper, then you've got 3x, which is steeper still. So essentially, I'm kind of spotting a pattern here as well. The bigger the number in front of the x, the steeper or the bigger the gradient of the line. And there's one last thing that we need to look at. We can look at some negative numbers. If I change all these to minuses, we get the lines going in the reverse direction. Okay, so they all go upwards from bottom left to top right when the number in front of the x is positive, and they all go downwards when the number in front of the x is negative. So at that point, I'm going to flip back to my PowerPoints, and I'm going to also take a little pause and see if anyone's got any questions about that so far. Feel free to write something in the chat if you want to ask questions. Otherwise, we'll carry on. Okay, so, and just to kind of give you a little bit of an insight into how this online learning would work in a normal scenario. The questions that I'm going to teach to you today, normally you would have a copy of these in front of you. So obviously, at the moment, I don't know any of you, and as a result, it's very one way this, but normally in a normal lesson with my students, they would be kind of talking back to me, telling me what they're spotting, and they'd be helping me answer some questions in a minute. So hopefully though, this is a good enough taster experience for you to kind of get a feel for how it works anyway. So let's go back to the PowerPoint. So I put a summary of my results here. So I said y equals x plus 2, it crosses the y-axis at 2. Y equals x plus 3, that crosses the y-axis at 3. Y equals x plus 5 crosses at 5, x minus 4 crosses at minus 4, and x minus 1 that crosses at minus 1. Okay, so that's the results so far that we've found. Now, in general, we could use some algebra to describe this. We could say if x plus 2 crosses at 2, then x plus c will cross the y-axis at c. Okay, so rather than have a number at the end, I've just replaced it with a letter, and the letter we normally use is the letter C. All these lines that we drew to begin with, they were all parallel, which say they've got the same steepness, and that steepness, we call that the gradient of the line. So that's the first thing I like everyone to see. Then the second set of graphs I drew were these ones, y equals x, 2x and 3x. Those lines, they got progressively steeper. That's because the number in front of the x gets bigger. Therefore, we say the gradient is changing. All those lines, they went in an upwards direction because the number in front of the x, proper name for a number in front of something is called the coefficient. That number in front of the x is positive. So if you look at the equations on the left, you've got a 1x, a 2x and a 3x. The numbers in front of the x are positive. Those numbers in front are called coefficients. Because they're positive, the lines all went upwards. I mean, the final 3 graphs that I drew were y equals minus x, minus 2x and minus 3x. They also got progressively steeper, but it was going in the opposite direction. And that's because the number in front of the x this time is negative. Okay, so we can actually make a general rule from this as well, ladies and gents. What we can say is if y equals mx, where m is the number in front of the x, if m is positive, the line goes upwards. If it's negative, the line will go downwards, and the bigger the m value, the steeper or the bigger the gradient is. So that's essentially the most important bit of theory, linking these equations with their graphs. Okay, so that's the facts. I'll take a short pause there. If anyone's got any questions, I'm just going to flick over to the chat. So either you're all very quiet or I'm doing a fantastic job here. So I'm going to carry on. So the next bit of the lesson, now we've spotted some patterns, I'm going to take a look at some exam questions. Now I'm going to do this in a little bit more of a traditional way. So I kind of want to get you to get a feel for what an actual exam paper would look like. So I'm hoping that, my camera seems to have frozen. Bear with me. Okay, I'm just going to restart an app. So, and I'm going to pop myself on mute. Hold on one moment. Unmute, there we go. Right, small technical blip there, but we're kind of well experienced at dealing with these by now. So, okay, so what I thought I would do is I've actually got a set of actual GCSE questions here. This is going to be a little bit more traditional, this part of the lesson. So I'm actually working on paper here for you, because I want you to all get a feel for how to set your work out. And sometimes when I'm simulating this on screen, it's kind of not a typical way how you would work in an exam. So I've got about 4 or 5 exam questions here that I've printed off, and I think we should use the theory that we've hopefully learned to kind of apply it to this. Now these questions take it a little bit further, so I apologise if my webcam refocuses occasionally, but it should be nice and clear for you all, but please let me know if there's any problem. So first bit says this. So here are the equations of 4 straight lines, line A, line B, line C and line D, and it says 2 of these lines are parallel. Which 2 lines? But before I explain that, let's just put a little summary of what we've learned so far. So we said, I wrote this, I said that y equals mx plus c. Now I said that the number in front of the x tells you the gradient. If that is positive, we said the line goes that way. If the number in front of the x is negative, it goes that way, okay? And this number tells us where it crosses the y-axis. So this equation I've written here, this is called the general equation of a straight line, y equals mx plus c. Now, I know a lot of my students that come from China, they don't know it like that. They call it y equals ax plus b. It's the same thing. But y equals mx plus c is the notation we usually use here in the UK. M just means gradient, c is the y-intercept. So if you want to solve an exam question on this topic, what you really need to do is you need to always make sure that your equation is in this format. It always needs to be in the format y equals something. So let's go back to this exam question here. So I've got line A, and line A is y equals 2x plus 3. Now that is in the form y equals mx plus c, because the thing in front of the x in this one is 2. Okay, so that has got a gradient, an m value of 2. Now this second equation, line B, that's not in that format. I need to rearrange that. So what I'm going to do, line B, I'm going to rearrange it as follows. I get 2y equals 6 minus 3x. And then I'm going to divide everything by 2. So I get y equals 6 divided by 2 is 3. And if I do 3 divided by 2, I'll get 3 over 2x, or I could use my calculator. That will give me the number minus 1.5. In fact, I'm going to put that bit first. I've got minus 1.5x plus 3. So line B is actually that equation. You always want it in the form y equals mx plus c. So on this one, m, the number in front of the x, we call that a coefficient, is minus 1.5. Okay. Now, let's keep an eye on the prize here. The question is saying, out of those 4 lines, which are parallel? Line A has got a gradient of 2. Line B has got a gradient of minus 1.5. That means one's going this way, one's going that way. They're going in opposite directions. They're definitely not parallel. Parallel means they're going in the same direction. Yeah, they maintain the same distance between each other. So let's look at line C. Line C is 4x minus 2y equals 3. I'm going to rearrange that. I could say minus 2y equals, I'm going to bring the 4x over here. Instead of positive 4x, it becomes negative 4x, and you've still got your positive 3. What I'm going to do, deliberate mistake I've just made there, that should say minus 2y. I wrote minus 2x. So minus 2y is minus 4x plus 3. I'm going to divide everything through by minus 2. I'm bringing the minus 2 over here. Now, when you do that, it stays negative, we just divide. So we get y equals minus 4 divided by minus 2 is 2. And if I do 3 divided by minus 2, that will give me minus 1.5. Okay, so what I have here for line C, the thing in front of the x is a 2. So that line C has a gradient of 2, and line A had a gradient of 2. So that means line A and line C, they've got the same gradient, so therefore they're parallel. Okay, question says 2 of the lines are parallel. Which 2? Well, you've just found it, A and C. We don't even need to muck about with line D because the question says only 2 of them are parallel, so no need making extra work for yourself, just work with those 2. So that's the first exam question done. That would be worth 2 marks on a past paper. Has anyone got any questions about the first part of that question? I'm just going to flip back to my chat thing. Okay, so first bit's done. Right, let's step it up. Let's make it a little bit more difficult now. So the second thing we're going to look at is this. It talks about line L. It says line L has a gradient of minus 5 over 2, and we're told that it passes through the point with coordinates 1, 3. We need to find an equation for L. Now, often the challenge with these questions is engaging with the language part of it, the comprehension skills. So here it says line L, it's got a gradient of minus 5 over 2, and we're told that a point that it passes through. Now, whenever a question says find the equation of the line, you need to prove to the examiner that you know what the equation of any line is. And the equation of any line is always y equals mx plus c. So if we write that down, that's 1 mark straight away. Now you can actually get a second mark for proving to the examiner you know which of those letters stands for gradient. The thing in front of the x tells you how steep something is, and the steepness, we call it the gradient. And we're told in the question that the gradient is minus 5 over 2. So I'm going to replace my m value with minus 5 over 2. So we get y equals minus 5 over 2x plus c. That's the equation of my line so far. Now we're also told some other facts, and this is where I need you to take a bit of a leap of faith with me, because this is a new concept. When I was drawing lines at the start of the lesson, I wrote down an equation on that piece of graphing software, and it drew a line. So basically that means this equation is closely linked with a picture of a straight line. And in this question, we're told that this straight line passes through the point with these coordinates. Now these coordinates refer to an x and a y value. Now what we've essentially got, I could do a little diagram, is we've got a straight line and it's going downwards because it's got a negative gradient, and it passes through the point 1, 3. That's what it's telling us. That basically means that this point lies on my line. In other words, this point has to obey the equation of this line. And if this point has to obey the equation of this line, it means the numbers 1 and 3 can be substituted into the equation. So in this equation, I've got a y, but my y value is 3. I've also got an x, and my x value is 1. And I've also got a plus c, and the whole point is we don't know what the y-intercept is. We don't know what c is. I'm going to try and work it out. So we get 1 multiplied by minus 5 halves is minus 5 halves plus c. Instead of minus 5 over 2, bring it over here, we get 3 plus 5 over 2. So we're going to get c equals, and remember, GCSE is a calculator paper. You can work that out on your calculator. But I'll do this in my head. 3 wholes, we call that 6 halves. 6 halves plus 5 halves is 11 halves. So we've now found our c value. Question wants the equation of the line. Equation of the line is y equals mx plus c, but we need to know m and c. We know m was minus 5 over 2x, plus our c value, which we now know is 11 over 2. So what we've essentially done is found the equation of our straight line using all the facts that they've given us. But there's a bit of a twist on this one. On this one, it wants the answer in the form ax plus by plus c, where a, b and c are integers. So a couple of key words for you today we've met. We've met the word coefficient. Coefficient is the thing in front of a letter. The coefficient of x in this case is m. Also, another new word, integers, that means whole numbers. So we want this written with whole numbers in. At the moment, we've got fractions. Nobody likes fractions. So I'm going to multiply everything by 2. 2 times y is 2y. 2 times that, do it on the calculator, will give you that. And 2 times that gives you this. Last thing they want is they want ax plus by equals c. So I'm going to bring this x over here. Instead of being a minus, it becomes a plus. So 5x plus 2y equals 11. Now at this point, some of you might think I've completely lost you. So I want to put your minds at rest. I don't know any of you, and this is actually quite a tricky topic to do, okay? If you've never met this idea of rearranging equations, then don't worry. If you're doing the GCSE program, I'm going to explain all of that to you before we even do this topic. If you're maybe thinking about A-levels, this may seem very easy to you, but I can always guide you as to what course is the most appropriate. So do not worry. I just want you to get a feel for what GCSE questions look like and get to know me a little bit. Okay, right, let me take a pause there. Let me see if anyone's got any questions they want to ask. Okay, yes, Tatiana has asked me a maths question. Wonderful. Let's hope I can answer it. Could you remind what are the gradient and equation? Yes, you're quite right. So m is the gradient. So m is the gradient. That tells me how steep something is. And c refers to the y-intercept. And when you put all that together in this little thing here that's got an equals in it, that's called an equation. So an equation is something that's got an equals in it. And then in this particular equation, m is the gradient and c is called the y-intercept. It's where it crosses the y-axis. I'm hoping that's answered your question, Tatiana. Good question, though. If it hasn't, let me know, and we'll come back to that in a sec. Anyone else got any questions? Okay, perfect. So let's take a little look at a second question. Now, second question I've got is this. As I say, it's a really good way of getting a feel for how to set your work out. So when we do GCSEs, it's a pen and paper exam. I want to model to you how you should set your work out. And sometimes actually physically write on the piece of paper, you're quite restricted with space. So number 15 says this, line A has this equation. Now, do you know what? As soon as I see that, I'm not even going to read the rest of the question because that's worrying me. When I see an equation like that and it tells me it's a line, that's not what I know to be a line. Going back to, I think it was it Tatiana? She asked me a question. She said, what was the equation of a line? The equation of a line needs to look like this. It needs to look like y equals. And this is not y equals. So what I'm going to do first of all, I'm going to rearrange this first equation. So line A is 3x minus 4y equals 5. Okay, I'm going to rearrange that. I'm going to bring, I can either bring the 3x over here or the 4y over here. I just want to get in the form y equals. I think maybe to get the y on its own on the left, I'll bring the 3x over here. And you can either put the 3x before the 5 or after the 5. Please excuse my webcam just focusing there. It does do that occasionally. So this 3x at the moment is positive. When I bring it over here, it becomes negative. So I will get minus 4y left behind equals, instead of positive 3x, bring it over here, it becomes negative 3x. And I've also got plus 5. Now I need to get y on its own. To get y on its own, I'm going to divide by negative 4 because this means minus 4 multiplied by y, or y multiplied by minus 4. And the opposite of multiplying is dividing. So I need to divide both of these things by -4. Okay. Now, minus and a minus, and again, if you don't know your negative numbers, don't worry, we'll cover all that in the GCSE course. Minus and minus make a plus. The way I remember it, if you look at my webcam, two minus signs, put them together, make a plus sign. Minus and minus make a plus, you get 3/4 x. Plus and a minus make a minus. The way I remember that is it's a competition between a plus and a minus, and the minus always wins. So we get -5/4. So that is the equation of line A. Now that's really useful now. So going back to, I'm terrible at remembering names sometimes. Yeah, so going back to what Tatiana asked me a minute ago. So the number m, the thing in front of the x, the thing in front of the x is 3/4. That's the gradient. I'm going to write that down. M in this case is 3/4. The reason why I focused in on that will become clear. It also tells me that line B goes through this point. So we've got two lines here. We've got line A and we've got line B. Line A, I've dealt with that one. I'm going to look at line B now, and I want to find out if line B is parallel to this one. If it's parallel, it will have the same gradient. Now, they've been quite nasty to us. They haven't given us any facts about line B, about its gradient. They've just told us 2 points that it passes through. In fact, I could draw it. We've got a line B. I'm going to assume for argument's sake it's going this way. We don't need to worry which way it's going essentially at the moment, but it's got 2 points on it. We've got the point -1,3, and we've also got the point 4,7. Now, at this point, I need to introduce a new bit of theory. So don't worry, there'll be more questions in a normal lesson that we use this bit of theory. But this is just an introduction. Now, I want to find the gradient of this line B. Now, gradient is how steep something is. And the mathematical way of defining gradient is we say it's the change in height over the change in width, or the change in the y over the change in the x. We sometimes write things like this. You may have seen this before. At GCSE, we don't really write that. At GCSE, we just write a little formula that's going to help us work it out. The formula, the change in y, is that over the change in x, which is this. So I'm going to use these numbers here in this formula to help you find the gradient. Now I'm going to label these points. We know the first number you get is an x coordinate, and the second number you get is a y coordinate. X and y, x and y. Now I'm going to call this one x1, y1, and I'm going to call this one x2, y2. Doesn't really matter which way you label it. As long as the first number is an x, the second number is a y. I could have called that x2, y2, and that one x1, y1. So I'm going to put those numbers into this formula. So I'm going to get the gradient is y2 take away y1. So that'll be 3 take away 7 over x2 minus x1. x2 is -1 minus our x1 value, which was 4. Okay. 3 take away 7, again, is a calculator paper. Don't worry if you don't know your negative numbers. We get -4. And -1 minus 4 is -5. Minus and minus make a plus, so I get 4/5. So what we've got is this. We've got two lines. Line A had a gradient of 3/4. Line B had a gradient of 4/5. Line A and B, they've got different gradients. Different gradients means they're not parallel. If it's the same gradient, they're parallel. If it's different gradients, they're not parallel. So are lines A and B parallel? Not parallel. Because they've got different gradients. I'll move my page up in a sec. You just put a little explanation, okay? So one of the skills at GCSE is you need to be able to articulate in English your explanation as well, okay? Right, at this point, it is quite intense, this. I just want to check in if anyone's got any questions. Let's have a little look. So Marina says they're not parallel. M for the second is 5/4. So you're right, they're not parallel. I've got M for the second was 4/5. It looks, yeah, it looks like that's a really common mistake, Marina. You have done the change in x over the change in y. But fair play to you for having a go at home. It's a shame I don't know you, because we could be engaging over the internet connection here, and you could tell me your thoughts on how to work up. Typo mistake. Okay, fair enough, very good. But it looks like you already know some stuff about straight line graphs. So at this point, let me just check in with John and Yuki. I think we have time to do one more question, perhaps?
Yeah.
Perfect. Okay, so let's have a look at one more. Let's take this a little further, ladies and gents. Now, I do apologise. As I've said before, in a normal lesson scenario, I would actually share this document with you on a shared folder, and you could then have a hard copy of it, and you can read this graph a little better. But I'm hoping it's clear enough for you to see here. Now, on this one, I've actually drawn a graph, and it says the points with coordinates 0, 3 and 8, 5. So 0, 3 is here, 8, 5 is here. We're told that they lie on the straight line L. Now, we've got to work out the gradient of L. So the good news is there's nothing new here. Gradient is how steep something is. Gradient, we use the letter M. And on the last question, I just gave you a formula for M. I said it was y2 minus y1 over x2 minus x1. Okay? Now, all we need to know is what are our x1s and y1s and etc., etc. Well, we've got 2 points on the line up here. In fact, you don't even need to check what those coordinates are, because they tell it to you in the question at the start. They give you some points. So I'm going to call this first point x1, y1, and I'm going to put the second point, I'm going to call it x2, y2. So I'm going to replace these numbers here in this formula. So I'm going to do y2 take away y1. So that would be y2 is 5 and y1 is 3. So we'll do 5 take away 3 over x2 take away x1, which would be 8 minus 0. That's going to give me the gradient. 5 minus 3 is 2, and 8 take away 0 is 8, and 2/8 cancels down to a quarter. So there you go. That's the gradient of the line out. As simple as that. The only thing that's the skill here is this formula. You need to memorize that at GCSE. You do get a formula booklet, but that is not one of the formulas that they will give you. Okay. Second bit, write down an equation of L. So now this is only worth 1 mark, this. Usually, if you want to write down an equation of a line, if you write down y equals mx plus c, you'll get a mark straight away. In this case, writing that down, that's not going to get you the mark. We need to find m and c. So we want the equation of our line L. L up here, we just found its gradient was a quarter. So that means our m is 1/4. So we've got y equals 1/4 x plus our c value. And you may remember c is where it crosses the y-axis. Here's my y-axis, and it crosses at the number 3. So the equation is 1/4 x plus 3. Now, sometimes they're a bit fussy about the format they want that in, but in this question, it just says write down an equation of the line, leave your answer like that, and that will get you the mark. Okay, final part of this question, excuse me. The final part says this: find an equation of the line which is parallel to L. Let's think about that. Parallel to L means it's going to be the same gradient. And we're also told it's got to pass through the point -4, -2. So if it's parallel to L, same gradient. L had gradient of 1/4. And we're finding an equation of a line. So show the examiner you know what the equation of a line is. Y equals mx plus c. We know it's got the same gradient, so m's got to be the same. Y equals 1/4 x plus c. Only thing we've got to do now is find what c is. Our line, I know it's going upwards actually, but it's got a positive gradient. It passes through the point -4, -2. That means that point lies on this line. This is the tricky bit. That means that point has to obey this equation. If it obeys that equation, it means you can put those numbers into that equation. So the y value is -2. the x value is -4 plus c. A quarter of 4 is 1, plus and a minus make a minus, plus c. Instead of -1, bring it over here, it becomes +1. -2 plus 1 is -1, so we'll get c is -1. Now you can see, even and I'm experienced at doing these questions, even I'm starting to run out of paper and space for my exam question. So this is why it's good practice to write on these actual exam scripts. So we've got y equals a quarter x plus our c value, and our c value is -1. We don't write plus -1, just write -1. So that is the equation of line L. Okay, so that's our second exam question done. Now at that point, I reckon we've got time for one more exam question, and then perhaps I'll do a little recap of some of the keywords and stuff, and we'll do some questions and answers and things. Okay, let me just check in my chat, just check if anyone else has got anything they want to ask. Okay, so let's have a look. Number 7. So 2 points, A and B, they're plotted on a centimetre grid. We're told that A has coordinates at 1, 4. You can check that. 1, 4. That's where its coordinates are. And B has coordinates at 8, 2. And we need to work out the coordinates of the midpoint of AB. Now, this is a little new. This is the final concept I'll introduce to you for the day. So we want to find the midpoint of AB. So one way of doing it would be to draw a straight line, join them up, and I could use my ruler even. I could physically measure where the midpoint is and mark it, and then read off the coordinates. That would be one way of finding the midpoint. Looking at what I've done, the midpoint appears to be at 4.5 and 3. So that is one way of finding the midpoint of a straight line. Sometimes that's not always very practical. Sometimes if you've got a scale that's not numbered very nicely, it gets tricky. Sometimes if I haven't drawn the graph, then you don't really want to have to draw a graph in an exam situation. You just want to find a quick way of finding midpoints given coordinates. So there's a real easy way of doing it. I'm going to make something up to show you. If I had, I'll do it up here. If I had the number 1 and 3, and I want to know the number in the middle, I'm hoping we all know the number in the middle of those is the number 2. But it's a really easy way of finding that. You add these and you half your answer. So 1 add 3 is 4, and if you half 4, you get 2. We can use that idea with midpoints on coordinates. We need to find the midpoint of the x values and the midpoint of the y values. So what I would do is I would add my x values. That's an x value, and that's an x value. So 1 add 8, and then you half your answer. And I do the same with my y values. I do 4 add 2, and I half my answer. Excuse me. 1 add 8 is 9, and if you half 9, you do get 4.5. 4 add 2 is 6. If you half 6, if you divide it by 2, you do get 3. In fact, excuse me, we can even write that in algebra if you want to really show off, and I don't give this formula to you, but I strongly recommend all my GCSE students memorize it. If you want to find a midpoint, what we do is this. We add our x values and we half them. We add our y values and we half them. And that will give you midpoint. Okay? So, final thing, and I don't want to kind of overload people with information, but this is really the last bit of theory that I would need to do. And then after this, in a normal lesson scenario, we would just practice these concepts time and time again until they stick. Okay? So the final thing I'm going to do is this. Use Pythagoras' theorem to work out the length of AB. Give your answer to 3 significant figures. So I want to find the length of this line here. Now, when it says find the length of it, it doesn't mean in centimetres. We need to work it out mathematically. And it's given us a hint, Pythagoras is our man. Pythagoras' theorem is a squared plus b squared equals c squared. When we write this, we always use lowercase small letters. Okay? Now, I'm going to make a right angle triangle here. Please excuse me covering obscuring the question for a moment. Now, I'm going to find the height and width of that triangle. The height of this triangle, we start at 2 and we go 3, 4. We've gone up by 2. The width of the triangle, I started at 1 and went across to 8. The width was 7. And I've made a cheeky little right angle. Okay. Now I want to find the length of this side AB. In Pythagoras' theorem, side C is the one that's always opposite the right angle. So my side C, in this case, is the line A to B. So I could call that AB squared. And side A and B are the other two sides. They are 2 and 7. So I'm going to replace A and B in this formula with 2 and 7. 2 squared is 4. 7 squared is 49. It's helpful if you know your square numbers, but again, it's not essential GCSE. We'll take care of all of that. 49 plus 4 is 53. So AB squared is 53. And at that point, I need my calculator. So AB will be the square root of 53. I do have my calculator here. Little tip, invest in one of these for GCSE and A-level. Really good calculator. I don't work for Casio, but I do thoroughly recommend them. And as a decimal, that comes out to be 7.28 to 3 significant figures. Okay, and that will get you your final 4 marks for that one. It's a big question. Okay, so hopefully that's given you an insight into straight line graphs. Let me just go back to my PowerPoint quickly. Right, at the very beginning, our objectives were discover the connection between the equation of a straight line and its graph. So that was the bit when I drew it on the computer, when I drew the lines. Hopefully you spotted the number in front of the x changes the gradient. If the number in front of the x is the same, then that means the line's going to be parallel. Parallel means they've got the same steepness. Recognise the effect that gradient has on a line. So the bigger the number in front of the x, the steeper it is. Locate an axis-intercept, so C, that thing is called our y-intercept. We're only really interested at this stage in our y-intercept, and we've done a few sample GCSE exam questions. So to put your mind at rest, as I say, if that was confusing for you, don't worry. When you start, hopefully at DLD College, I'll get to know you, I'll find out your weaknesses. We'll start from the ground up, so you're in safe hands here. Let me just flick to the end of my slides. So Q&A. I don't know if at this point John and Yuki want to step in. If anyone's got any questions, if you want to pose them.
Yes, Pat, thank you. Oh, hi, Yuki. I'll just go first, then I'll hand over. If anyone wants to put any questions in the chat, please do. I know my colleague Yuki has a couple of questions that she's received, and she's going to put to Patrick in a moment. But please post your questions in the chat or the Q&A boxes, and we'll put those to Patrick. Yuki, I'll pass over to you.
All right. Okay. Thank you. I think it's a great lesson, and kind of reminds me of my my long time ago studied mathematics, and it's always fun to me. Anyway, I guess I would start a few questions, and can you please advise students on how to prepare GCSE maths or A-level maths before they start with us in September?
Sure. So I think the expectation for GCSE maths, I'm very used to having students that either have not done maths for a very long time, or they've got gaps in their knowledge. So the first thing I want to say is you're in very safe hands here. We start from the ground up. In terms of expectations of what you could do to prepare, I think the best thing is you could do a little bit of study on over the summer break, would just be some basic number work and some simple algebra. So if I was to pick a couple of topics that I would love you to already understand, it would be things like simplifying algebraic expressions and just doing some basic rearranging of equations. If you could do that before you can come to me, then that makes my life a little bit easier. And if you know things like your basic arithmetic, like your times tables and stuff, that helps a lot as well. For some of you, that may seem very basic, but if you know that already, then that's great. There are some sample websites I can send certainly forward to Yuki that you can refer to that might be able to help you in that preparation. And I think it would be useful if I send to Yuki a sample GCSE past paper, and then that will give you an insight into some of the topics that are tested, and you'll get a bit of a feel for the sort of maths you'll be covering. So you could look at a past paper and from the EdXL exam board as well. Okay.
Yes. That's great. Thank you. So about A levels, and I thought you just mentioned about GCSE. Maybe there are a couple of audience applying to us for 2-year A level. And do you have any advice on that?
Sure, yeah. I mean, I think it's very important you've got a good grounding in GCSE. There is a temptation to kind of try and embrace the A-level program, but on a rocky foundation. So I'm a firm believer, let's do things once, let's do them properly, and then you set yourself up for success. So I guess in terms of requirements to do an A-level, you really do need to have minimum, I would say, a level 7 at GCSE, but we do take it on a case-by-case basis. If you've got a 6, we will certainly have that conversation with you, but it would always be subject to an entrance exam. Ultimately, we want you to leave a satisfied customer. We want you to feel that you're making progress, and to do that, we need to set you up for success in the first place. So you need to kind of fulfill some minimum entry requirements there. In terms of the further maths program, that is a really, really rigorous A-level. So we'd be really looking at you having an 8 at GCSE if you decide to sign up to the further maths. And again, it's just because it's in your best interest. We want you all to succeed.
That's great. Thank you. So yeah, we basically students do what they can do at their best to prepare for the lessons, but we will definitely pass down some materials or useful websites for our audience today. And yes, so I think that's all from me, and I haven't seen any questions from our audience. I assume everything is fine. Thank you very much, Patrick, and yes. Thank you everyone for coming today, and we have more sample lessons planned. Please check our website and join us, and thank you and have a lovely day. Bye-bye.
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 Thank you very much. Bye-bye.